Hello everyone, welcome back. So in the previous video, we understood about the Kubernetes architecture using a simple company example. Now in this video, we will go deeper and understand how Kubernetes work internally, what happened inside the control plane, how worker node works, and how Kubernetes automatically manages the application. So let's get started. So at the very high level, Kubernetes cluster consists of two major parts. First is the control plane. Control plane is the brain of the Kubernetes. And second is the worker node. Worker node is the machine where actually we run the application. So developer creates the YAML file, apply using a kubectl command, and then request go to the control plane. The control plane process the request and send the instruction to the worker node. Then worker nodes create support, start the container and run the application. Now let's understand the control plane component. So first we have a Kube API server. The Kube API server is the entry point for the Kubernetes. So whenever a developer runs the kubectl command, the first request go to the API server, and then API server validate the request, check the authentication, check the permission, and communicate with the other Kubernetes component. So you can think API server is the first front door for the Kubernetes. So every component communicate through the API server. Next, we have etcd. So etcd is the database for the Kubernetes. It stores all the cluster informations like pod, node, deployment, configuration, and cluster state. For example, which pod is running on which node, how many pod exit, and the current cluster state. So everything is stored inside the etcd. Only the API server directly communicate with the etcd. Next, we have a kube scheduler. The scheduler decide which worker node should run a pod. Whenever we create a new pod, the scheduler check all available worker node and select best worker node based on the CPU availability, memory, resource uses, and node health. For example, if an application requires one CPU, 2 GB of RAM, the scheduler find the most suitable worker node for the pod. Next, we have a Kube Controller Manager. The Kube Controller Manager continuously monitor the Kubernetes cluster and ensure everything is running as expected. So its job is to compare the desired state and the actual state and automatically fix the issue. For example, if your application should run with 3 pods but one pod crashes, the controller manager automatically create a new pod and maintain the required number of pods. We have a different controller. The deployment controller maintains the required number of pods. Node controller continuously check whether the node are healthy or not. Replication controller ensure the correct number of replica are running. Job controller manage the batch and schedule job. And endpoint controller update the service endpoint. Now let's move to the worker node. Now each worker node contain Kubelet, Proxy, and container runtime. Now Kubelet is the Kubernetes agent running on each worker node. So its job is to receive the instruction from the control plane, ensure container are running, monitor the container health, and send the update back to the Kubernetes. A kubelet makes sure everything on the node work properly. Next, we have a kube proxy. So kube proxy is the networking proxy component that run on each worker node in the Kubernetes. And the main job is to manage the network communication inside the Kubernetes cluster. For example, you have 3 pods running for your application. Kube proxy automatically route all incoming traffic to the available pods. If one pod become unavailable, Kube proxy redirect traffic to the healthy node. Next, we have a container runtime. The container runtime is responsible for running the containers. Popular container runtime are containerd, CRIO, and Docker. The job of the runtime is to pull the Docker image, create the container, and start the application. And this is where the actual application finally runs. Now let's understand the complete workflow. So first step, developer write the YAML file. In the second step, the YAML file is applied using kubectl apply. In the third step, the request go to the API server. In the fourth step, API server store all the cluster information inside the etcd. In the fifth stage, scheduler select the best worker node. In the sixth stage, kubelet receive the instruction from the node. In the seventh stage, container runtime pull the Docker image and create the container. In the eighth stage, pods start running and application becomes live. In the ninth stage, Kubernetes continuously monitor the applications. If the pod crashes, Kubernetes automatically create a new one. So why Kubernetes is so powerful? Now Kubernetes is powerful because it has features like auto scaling, self-healing, zero downtime deployment, automatic rollback, and high availability. And that's why Kubernetes is widely used. So let's quickly recap. The control plane components are API server, etcd, scheduler, and controller manager. And worker node components are Kubelet, Proxy, container runtime. So we have a workflow like a developer, API server, etcd, scheduler, worker node, pod, container, and application running. Thank you for watching, and I will see you next video.